Hello and welcome to a GCSE walkthrough for the maths exams that are coming up shortly, and I'm going to be doing the higher tier paper for this video, and we're looking at paper 1, which is the non-calculator paper. I am also going to do paper 2 and paper 3 shortly, and I have also done the paper 1 foundation. So if you are doing foundation, make sure you check that out. And also in the video description, I'm going to put a link to all of my walkthroughs because I've done loads of these in the past. So the best way to revise is to do past papers at this stage anyway. So try and do as many past papers as you can. And also in the video description, I've put a link to this specific paper. So I would encourage you to have a go at the paper first. And then when you finish that, come back to the video and go through the answers. And one more thing, I have got chapter headings which go along the bottom of the video. So when you want to check specific questions, you can just click on those chapter headings and that will take you straight to that question. So I think that's everything covered. So without further ado, let's get cracking with question number 1. So question 1 has 5 parts to it. A shop sells umbrellas. The scatter graph shows the information about the number of umbrellas sold each week and the rainfall that week in millimeters. So you can see along the x-axis we've got the rainfall in millimeters, and on the y-axis we've got the number of umbrellas sold. So part A, describe the relationship between the rainfall and the umbrellas sold. So the relationship, if we look at the scatter diagram, we can see that this is a positive relationship, or we would say a positive correlation. So that's all we need to say. We just need to say a positive correlation. That will give us our 1 mark. So let's look at part B. What is the most number of umbrellas sold in 1 week? So the number of umbrellas is along the y-axis. So we're looking for the highest value, and we can see that it's this one here. So how many umbrellas is that? Well, we've got 105 here and 120 here, and we've got 1, 2, 3, 4, 5 squares, 5 small squares between each of these points. So to go from 120 to 105, that's a difference of 15. So if we can just do 120 minus 105, which is 15. And we can see there's 5 small squares between these two. So if we just divide that by 5, that will give us 3. So each small square is worth 3 umbrellas. So if this here is 105, that's going to be 108, 111, 114. So our answer is 114. Okay, part C. In how many weeks did the shop sell over 105 umbrellas? So 105 umbrellas, well, we're looking along this line here. So we've already seen this one was over 105. This one's over 105. And this one's over 105. All the rest are less than 105. So there were 3 weeks. So my answer for this is just going to be 3. Okay, part C. In another week, there was 6 millimeters of rain. Estimate the number of umbrellas sold. So this time we're looking along the x-axis. There was 6 millimeters of rain. So 6 millimeters of rain. Oh, let me use the black. So we need to go up and estimate how many umbrellas were sold. Now to do this, we're going to have to draw a line of best fit. So you will need your ruler for this. I don't have a ruler, so I'm just going to use the line tool on Microsoft Paint. So I'm just going to try my best to draw a line in that is roughly a line of best fit. I think it's going to be something, maybe something like that. Okay, you should, just a rule of thumb, you should have roughly the same number of points below the line and above the line. And actually, I can see that's not quite right. I was forgetting these ones in red. So let me just change that slightly. I think it's probably going to be about there. Okay, we've got about 6 or 7 below the line. 1, 2, 3, 4, 5, 6, and we've got 7 above the line. So that's about right. And now what we can do is if we go along to 6 millimeters and then go up until we hit the line, well, it looks like on my line I get exactly that point there. And then if we go along, that corresponds to 45 umbrellas. So it's key here to see that this is only an estimate. We can't say for sure that there's going to be 45 umbrellas sold. And in the mark scheme, there will be margin for error. So there will be a lower and upper bound. And if you've drawn your line accurately, hopefully you'll be within that. Part E, explain why it may not be appropriate to use your line of best fit to estimate the number of umbrellas sold in a week with 25 millimeters of rainfall. So why was it okay to estimate the number of umbrellas sold with 6 millimeters of rainfall, but it's not okay with 25 millimeters? Now the key thing here is to do with our data range. Notice the data goes from 5 millimeters up to approximately 13 millimeters. So if we've been given rainfall between these two values, we can use that to use our line of best fit. But if the data is outside our data range, we can't, and that's called extrapolation. So we can say that we only have data up to 13 millimeters of rainfall. Okay, so if we've been given a rainfall outside of this data range, then we can't use that to estimate the number of umbrellas sold. So we can only do it for values between 5 and 13. Question 2, write 60 as a product of its prime factors. So I like these types of questions. So we're going to start with the number 60, and we need to break this number down into the smallest parts possible, where all of the numbers that make up the number are prime. So how can we break up 60? Well, there's loads of different ways we can do it. I'm just going to start off by saying 60 is equal to 10 times 6. You could have used 12 times 5 or 30 times 2. Loads of different ways you could do it, but I'm starting it off like this. Now with 10, we can see that 10 is definitely not prime. So we're going to have to break 10 down, and 10 is the same as 2 times 5. And exactly the same with 6. We can see that 6 is definitely not prime, but 6 is the same as 3 times 2. So it's going to be 2 times 5 multiplied by 3 times 2. And notice these are all prime numbers, so we are done. We could leave it like this. That would give us our 2 marks, but I'm just going to tidy it up because we can simplify this. So you can see that we've got 2 times 2, that's the same as 2 squared. And then I'm just going to put it in numerical order. So times 3 times 5. So I'm going to leave that as my answer. 2 squared times 3 times 5. Now, for this particular question, you would get 4 marks if you were to leave it like this. But if the question said, write your answer in index form, then you would need to write it like this. Otherwise, you would lose marks. Question 3, work out 412.8 divided by 24. Might look a bit complicated, but I'm just going to change this calculation. Instead of doing this, I'm going to do 4,128 divided by 24. These two calculations are exactly the same. The reason for that is because I've multiplied this number by 10 and I've also multiplied this number by 10. So I'm not changing the value of the calculation. So let me just write this as a fraction. We've got 4,128 divided by 24. There's loads of ways you could do this. You could just do straight up long division and just, divide this by this. But what I'm going to do is I'm just going to do it in steps because I can see that both of these numbers are even. So we can obviously divide both numbers by 2. So I know if we divide both numbers by 2, the denominator is going to be 12. The numerator, let's just do that. So let's just do the bus stop method. So 4, 1, 2, 8. 2's go into 4 twice. 2 doesn't not go into 1. So we're going to move the 1 over here. 2's go into 12 6 times and 2 goes into 8 4 times. So it's going to be 2,064 over 12. These numbers are still both even, so I can divide by 2 again. So we're going to have 6 on the bottom. in the numerator, I'm going to have 1032. I can just see that if I divide 2000 by 2, I'm going to have 1000. If I divide 64 by 2, I'm going to have 32. I can divide by 2 again. So the denominator is going to be 3. The numerator is going to be 516. Again, that's just visually looking at this. Half of 1000 is 500. Half of 32 is 16. And now we're left with 516 divided by 3. So for this, I'm just going to do the bus stop method again. 3's into 516. 3 goes into 5 once with 2 remainder. 3 goes into 21 7 times exactly. And 3 goes into 6 2 times exactly. So here's my answer, 172. And like I said, there's loads of ways you could have done this. A lot of people will just do 4,128 divided by 24 using the bus stop method. But this is how I did it. So either way, as long as you get the right answer, we're all good. Question 4. A rectangle is shown below. The length of the rectangle is x plus 9 centimeters. And the width of the rectangle is x minus 1 centimeters. Form an expression for the area of the rectangle. So to calculate area, we know that area is just base times height. So the base is x plus 9, so it's going to be x plus 9. And the height of the rectangle is x minus 1. X minus 1. Now, we have formed an expression for the area, but it probably wants you to expand this out, I would say. Because it's 3 marks, this is definitely not enough for 3 marks. So we're definitely looking to simplify this. So we've got double brackets. So the way I like to do this is, you may have heard of FOIL before. So FOIL just stands for first, outside, inside, last. So the first terms, x times x, well, that's going to be x squared. The outside terms is going to be x times negative 1, which is negative x. Then the inside terms are 9 times x, which is positive 9x. And finally, the last terms are positive 9 times negative 1, which is negative 9. And we haven't quite finished because we can simplify this. So we've got x squared. Now we've got like terms. We've got negative 1x plus 9x. Well, that's going to be plus 8x. And then we've just got negative 9 hanging out the back there. So this will be my final answer. So A equals x squared. Actually, I'm not going to write A because that's an equation. So what I've got here is an equation. It's asking me to form an expression. So this is an expression. This whole thing would be a formula, but it's asking for an expression. I don't know if you'd lose marks if you put A equals, but I'm going to play it safe and just write the expression. X squared plus 8x minus 9, and we are done. Question 5. Shown is a right angle triangle. Work out the area of the triangle. So to calculate areas of triangles, well, we've got a right angle triangle, so it's just going to be half the base times the height. But we don't know the height, so we're going to have to work out the height. We do have the hypotenuse, so I'm thinking Pythagoras. That's the first thing that comes into my head. So the Pythagoras theorem states that if we call this A and this B and this C, we know that A squared plus B squared is equal to C squared. So A is 12, so it's going to be 12 squared plus B squared, that's what we're trying to work out, is equal to C squared, so 15 squared. So what do we have? We've got 12 squared, well, that's 144, plus B squared, and that is equal to 15 squared, which I know is 225. If you didn't know that, then you could just do 15 times 15, long multiplication, or the grid method, or however you like, but you will get 225 when you do that. Now we want to calculate B. So let's get B squared on its own first. So if we subtract 144 from both sides, what are we left with? Well, we've got B squared is equal to 225 minus 144. So let's just do it like this. 5 minus 4 is 1. 2 minus 4 we can't do, so we're going to have to borrow. So now we've got 12 minus 4 is 8 and 1 minus 1 is 0. So it's just 81, and that's nice because 81 is a square number. So B is just equal to the square root of 81, and it's the positive square root. We can't have a length that's negative, so that would just be stupid. So B is just equal to 9. So let's pop that in there. Let's do it in blue, so we're matching. We're matching, and it is in centimeters, obviously. So now let's calculate the area. So our area is equal to a half times the base, which is 12, times the height, which is 9. So half of 12 is 6. 6 times 9 is 54. So it's going to be 54, and our units are going to be centimeters squared. Make sure you write your units. Sometimes the units are given to you, but they're not here. So make sure you include your units. Otherwise, you could potentially lose marks. So I'm going to write the whole thing. 54 centimeters squared. Question 6. Lines A and B are parallel. Line A passes through the point 0, 8, which we can see. And line B, we're told what the equation is. Y equals 3x plus 1. Write down the equation of line A. So if we just think about how we write down equations of lines. So the most common way we would do it is in the form of y equals mx plus c, where m is the gradient and c, let me just do it like that. C is the y-intercept. Hopefully this is familiar to you. Now we're told that these two lines are parallel. That's really important because that means that the gradients are the same. Now, if we're looking at the equation of line B, we can see that the gradient is 3. It's the letter in front of x, or the number in front of x. So it's going to be exactly the same for line A. So we know it's going to start with 3x. Okay, the gradients are exactly the same because they're parallel. Now we just need to work out what the y-intercept is. And that's quite nice because we're told that it passes through the point 0,8, which is the y-intercept. So anything with a 0 as the x value will be the y-intercept. So we can see that it passes through where y equals 8. So it's going to be y equals 3x plus 8. And that is our equation. So I'm going to write it down here. Y equals 3x plus 8. Question 7. 10 girls and 15 boys sit a test. The mean mark for the boys is 70 and the mean mark for the girls is 82. Work out the mean mark for the whole class. Now, there's a really big error that people make with these type of questions. All they'll do is add the two numbers together and then divide by 2. That is not how you answer these questions because the number of girls and boys is different. So what we're going to have to do is we're going to have to work out the total mark for the boys, the total mark for the girls, and then we can add those two together and divide by how many people sat the test. So the boys, let's start off with the boys. The boys, the mean mark was 70 and there were 15 boys who sat the test. So the total number of marks is going to be equal to 70 multiplied by 15. Hopefully you can see why that is. 15 boys sat the test and the mean mark was 70, so the total number of marks will be 15 times 70. So what's that? Well, 15 times 7 is 105, I believe. And then we can just add a 0 on the end there. So 1050 marks. That's how many marks the boys got in total. Now let's do the girls. So the total mark for the girls, total marks for the girls, well, that's going to be equal to 82 multiplied by 10. That's nice and easy. So that's going to be 820 marks. So now we can work out the total number of marks for all the students. We can just add these numbers together. So that gives us 1,870 marks. So to calculate the mean, well, the mean is going to be the total number of marks divided by the total number of students. Total number of students. So it's going to be 1,870 divided by 10 plus 15, which is 25. So we've got 1,870 divided by 25. Now, before I do this, I can simplify this because both of these numbers are divisible by 5. So I know that 25 divided by 5 is 5. I'm not sure what this divided by 5 is. Let's work it out. So 5's into 1,870. 5 doesn't go into 1. 5 goes into 18 3 times with 3 remainder. That 3 remainder. 5 times 3 is 15. Yep, 3 remainder. 5 goes into 37 7 times. 7 times 5 is 35. So we've now got 2 remainder. And now 5 goes into 24 times. So it's going to be 374 divided by 5. And now I'm just going to do division on that. So 5's into 374. I know we're going to need a decimal point because this is going to have a remainder. So 5 doesn't go into 3. 5 goes into 37 7 times. 7 times 5 is 35. So we've got 2 remainder. 5 goes into 24 4 times. And we've got 4 remainder. And let's just put a decimal point here. And 5 goes into 48 times exactly. So this is our answer, 74.8. So make sure you're not doing the very common mistake and just adding these two numbers together and dividing by 2. And let's just make sure that this makes sense. So if the mean mark for the boys is 70 and the mean mark for the girls is 82, we know that the overall mean has to be between these two values. Okay, so has to be between 70 and 82. This is sort of a sense check to do to make sure that your answer does make sense. Okay, and we can see that it is between those two values, so I'm quite happy that this is the correct answer. Question 8. Jacob buys a watch costing £84. This cost includes VAT at a rate of 20%. How much is the watch without VAT? So we need to work out the original price of the watch without any VAT. So what does that £84 represent? Well, that represents the original price of the watch plus 20% VAT. So if we think about the original price being 100% and then we're adding on 20% VAT, well, this £84, that represents 120% of the original price. So it's the original price, 100% plus 20%. So we want to work out how much the watch costs without VAT. So we're looking for 100%. So the cost at 100%. So a few ways you could do this. I think what I'm going to do is first of all work out what 10% is. So to go from 120% to 10%, well, I'm just going to be dividing by 12. So if I do that to both sides, divide by 12. 84 divided by 12 is 7. So that's nice. And now to go from 10% to 100%, I'm just going to multiply by 10. So I'm going to multiply the left-hand side by 10. 70, sorry, I've given you the answer there. 7 times 10, that gives us 70. So it's £70. And we can check our answer. So with these type of questions, I always encourage you to go forward and check the answer. So let's say we have got a watch, it costs £70, and then we add 20% VAT on. Well, what is 20% of 70? So 20% of 70, well, 10% is going to be 7, so it's going to be 14. So we can clearly see that if we add on £14, that does take us to our magic number of £84. So we know that we've got it correct. A big mistake people make with these type of questions is just to work out 20% of 84 and then take that away. But no, that's not how you do it. So try and get into the habit of doing it this way. I like to set it out like this, but it's up to you how you do it. But you just need to remember that that £84 represents the original price, the 100% plus the extra percentage, in this case 20%, and you're working backwards to work out what 100% is. Question 9, part A, express root 75 in its simplest form. So we're starting off with root 75. Now, the way I like to do this is try and think of two numbers that multiply together to get 75. So we're going to break this down. Now, 75 is the same as 25 times 3. So this is the same as the square root of 25 times 3. And now, using our Surd laws, we can write this down as the multiplication of two roots. So this is exactly the same as the square root of 25 multiplied by the square root of 3. And we can simplify this. 25 is a square number, so instead of writing root 25, we can just write 5. So this is 5 times root 3, or how we would write this is 5 root 3. So that's our answer, 5 root 3. Now let's look at part B. Arrange the following numbers in order, smallest to largest. So we've got 5 root 3, 3 root 10, 2 root 22, and 4 root 5. So the way I'm going to do this is I'm going to get all of the numbers into radical form, or I should say put all of them under a square root. So instead of writing 5, I know that 5 is the same as root 25. So instead of 5 times root 3, it's going to be root 25 times root 3, which is the same as the square root of 25 times 3, which is root 75. So I don't know if that's a coincidence. It's the same as this up here. But 5 root 3 is the same as root 75. Let's do exactly the same for this one here. So 3 is the same as root 9. So it's going to be root 9 times root 10, which is root 90. So that one is root 90. So root 75 is definitely smaller than root 90. So let's keep going. Let's use fuchsia for this next one. So 2, well, that's the same as root 4. So that's going to be root 4 times root 22, which is going to be root 88. So root 88. And then finally, I think I'm going to use a brown, or I'm not sure really what color. I think this is brown. So 4, that's the same as root 16. So it's going to be root 16 times root 5. And 16 times 5 is 80. So that's going to be root 80. And now we've got them all in this form, it's much easier to see which one is the smallest, which one is the largest. So smallest, this is going to be this one over here. Now remember to write it in this form, because this was what the question was in. So we've got 5 root 3, and then the next smallest is this one. So it's going to be 4 root 5. And the next smallest is this one. That's 2 root 22. And then number 4, the biggest one, is root 90, which is 3 root 10. 3 root 10, and we are done. Question 10, expand and simplify this expression here. Now, in a previous question, I used the FOIL method to expand brackets. So for this question, I'm just going to mix it up and use the grid method. So first of all, I'm going to expand these two sets of brackets. So we've got 1 and then negative 2x. And we're going to multiply that by x plus 3. So I'm just going to do a grid like this. So we need to multiply each term by each term. So we're going to have 4 terms. 1 times x, that's x. Negative 2x times x is negative 2x squared. 1 times 3, that's just 3. And then negative 2x times 3 is negative 6x. So if we write this out, and I'm going to simplify as well. So we've got negative 2x squared. And then if we simplify these two terms, x minus 6x, that's going to be negative 5x. And then we've just got plus 3. So now I've got my expression from the first set of brackets. I'm going to multiply that by this last bracket. So we've got negative 2x squared minus 5x plus 3. And then down this vertical, I'm going to write x minus 1. x minus 1. So this time we're going to have 6 terms. I'm just going to do my grid like this. Oh, bit of a wonky line, but should be fine. So let's go across. So negative 2x squared times x, that's going to be negative 2x cubed. X times negative 5x, that's negative 5x squared. And then x times 3 is 3x. And now we've got negative 2x squared times negative 1, well, that's just going to be positive 2x squared. Negative 5x times negative 1, that's positive 5x. And negative 1 times 3 is negative 3. So what does this equal? Well, let's start with the highest degree term first. We've got negative 2x cubed. And then these two terms will simplify. So 2x squared minus 5x squared, that's going to be minus 3x squared. Now let's simplify these two terms. 5x plus 3x is positive 8x. And then finally, we've just got that negative 3. So this is my final answer, negative 2x cubed minus 3x squared plus 8x minus 3. And for these type of questions where you've got triple brackets, I definitely think the grid method is probably the most efficient one to use. It just means that you're not likely to forget any terms. A lot of times when people are just drawing these lines in and multiplying terms just using what they've been given, sometimes you might forget some terms. But if you draw the grid, you know that you've got every term. And then obviously you need to simplify your final answer to get the full marks. Question 11, part A. Find the value of 100 to the half power. Now, whenever we've got a half power, that is the same as the square root. So this is just going to be the square root of 100, which is 10. So our answer for this one is just 10. Okay, let's have a look at part B. So again, we need to find the value. So let me just highlight that. Find the value of 4 to the negative 5 halves. So whenever we've got a negative power, that's always 1 over. So this here is going to be 1 over 4 to the positive 5 halves power. So we've got 1 over, and now if we focus on our denominator, the denominator of the power is the root and the numerator is the power. So it's going to be the square root of 4 to the 5th power. So it's going to be the square root of 4 to the 5th power. So again, the numerator is just 1. What is the square root of 4? Well, that's 2. So it's going to be 2 to the 5th power. And 2 to the 5th, that is 16, I believe. Oh, no, 32. I'm not quite sure. Let me work it out. So 2 times 2 times 2 times 2 times 2. Well, this is 4, 8, 16, 32. It is 32. So it's going to be 1 over 32. So that is my final answer, 1 over 32. And part C, this time we need to simplify. So we've got this expression, 27x to the power 6, and we're raising all of that to the power 2/3. So whenever we've got something in brackets which we're raising to a power, that means that everything in the bracket is being raised to that power. So we've got 27 to the power 2/3. So it's going to be 27 to the power 2/3. And then we've got x to the power 6. And we're raising that to the power 2/3 as well. So let's first of all evaluate what this is. So remember, the denominator of our power is going to be the root, and then the numerator is the power. So we're going to take the cubed root of 27 and then square it. So the cubed root of 27 is 3. 3 squared is 9. So this is going to be 9. And then over here, we can use our laws of indices. So when we raise something to a power and then raise that to a further power, we just multiply our indices together. So it's going to be x to the power of 6 times 2/3. Well, 6 times 2 is 12. 12 divided by 3 is 4. So it's going to be 9x to the power 4. So that is my final answer, 9x to the power 4. Question 12. The graph of y equals f of x is shown on the grid. Part A, write down an estimate for the coordinates of the turning point of the graph. So the turning point of the graph, well, that's going to be at this point here. Now this is only an estimate, so we're not looking for an exact value. So we're just going to read off the graph. So coordinates, we go along the corridor and then we're going to go down the stairs. So we're going to go, so this is -1 and this is -2. So it looks like each small square is going to be worth 0.2. So this is 0.2. Or sorry, -1.2, I should say. This would be -1.4, so I'm going to say -1.5. It looks like it's halfway. So -1.5, that's my x value. My y value, so it's between -4 and -5. So this is -4. This is -4.2. Because again, each one is 0.2, and it's just past that, but it's closer to -0.2 than 0.4. So I'm just going to say -4.2. So that's my answer for part A, and there will be slight margin for error on this, but try and get as accurate as possible. Now let's look at part B. Use your graph to find the value of f of 1.2. So we notice we haven't been given any equations here. All we're doing is reading from the graph. So f of 1.2. So this is x equals 1. 1.2 is here. So I'm just going to go up the grid until we get to the line. So it is about here, I think. So if we go along, we can see that is bang on 3. So that's my answer. My answer is going to be 3 for that one. Question 13. The force, F newtons, exerted by a magnet on a metal object is inversely proportional to the square of the distance, d centimetres. And we're told when d is equal to 2 centimetres, F is equal to 50 newtons. And part A, we need to express F in terms of d. So we need to write a formula for F in terms of D. Now we're told what the relationship is between F and D. We're told that the force is inversely proportional to, so this just means proportional. So this little symbol here means proportional. So if it's inversely proportional, we can say it is proportional to 1 over the square of the distance. So that's just d squared. So we've written out the relationship between F and D. Let's write this as a formula. So we can say that F is equal to some constant multiplied by 1 over d squared. So we could leave it like this, but we can simplify this slightly. So this is exactly the same as k over d squared. So F equals k over d squared. All I've done is I've just multiplied k by 1. So now we've got our formula. We don't know what our constant is at the moment, but we can work it out using the values they've given us. So we're told when d is 2, F is 50. So let's just plug these numbers into our formula. So when F is 50, we've got 50 is equal to some constant divided by d squared. Well, d is equal to 2. 2 squared is 4. So it's going to be k over 4. And now to work out what k is, we can just multiply both sides by 4. So if we multiply the right hand side by 4, those cancel. And then if we multiply the left hand side by 4, we just get 50 times 4, which is 200. So we've got 200 is equal to k. And now we've got our constant value, we can just plug this into our formula over here. So we're going to have F is equal to, instead of k, we can write 200 over d squared. And we have done it. We've written a formula for F in terms of d. So we've got F is equal to 200 over d squared. Okay, moving on to part B. Find the force when the distance between the magnet and metal object is 10 centimetres. So now we could just plug this value for our distance into our formula, and that will give us the force. So our force is equal to 200 divided by our distance squared. Well, we're told our distance this time is 10, so 10 squared. So it's going to be 200 over 100, which is nice and easy, which is 2. So our force is 2 newtons. Question 14. The cost of a mobile phone is X pounds and the cost of a television is Y pounds. When both prices are increased by £40, the ratio for the cost of the mobile phone to the cost of the television is 15 to 22. When both prices are decreased by £100, the ratio for the cost of the mobile phone to the cost of the television is 8 to 15. Find the values of X and Y. Okay, let's first of all focus on this statement here. So when both prices are increased by £40, so the mobile phone is X, so that's going to be X plus 40. So the ratio between the cost of the mobile phone to the cost of the television, well, the television is going to be Y plus 40 because they're both being increased by £40. So this ratio is equal to 15 to 22. 15 to 22. And now let's look at the other statement. So this time when both prices are decreased by £100, so that's going to be X minus 100. So the ratio of that to Y minus 100 is going to be 8 to 15. Okay, now so far we've written these out as ratios, but we can write, instead of writing these out as ratios, we can write them as fractions. So if we focus on the one in black first, this is exactly the same as if we were to say X plus 40 divided by Y plus 40 is equal to 15 over 22. Now, if you're a bit unsure of why this is the case, let's just briefly look at a very simple example. So let's just say the ratio 1 to 2. Well, hopefully you all know that the ratio 1 to 2 is exactly the same as the ratio 3 to 6. These are equivalent ratios. Or we could write them as equivalent fractions. So we could just say that if we write this as a fraction as 1 over 2, well, that's the same as 3 over 6. So all I've done is instead of writing them as ratios, I've written them as fractions. And that's exactly what I've done over here. I've written these ratios as fractions. Okay, let me just delete that because I'll probably need to use this space a bit later on. Okay, so now looking at this equation here, let's write this, let's simplify this. So I'm going to cross multiply. So I'm going to multiply by this side by 22 and this side by Y plus 40. So we're going to have 22 times X plus 40, and that is going to equal 15 times Y plus 40. So if we just expand the brackets now, we've got 22x plus 880, which is equal to 15y plus 600. And now if I get all of the x's and all of the y's on the same side, if I put them on the left hand side and put the numbers, if I put them on the right hand side and put the numbers on the left hand side, just so that we'd be left with a positive number. So if we subtract 880 from both sides and 15y from both sides, I'm going to be left with 22x minus 15y is equal to, no, sorry, I've done that the wrong way round. I want to get all of the numbers on the left hand side. So 880 minus 600 is 280. So we're going to have 280 on the left, and on the right hand side we're going to have 15y minus 22x. Okay, so we've got an equation here. We've got two unknowns, so we can't solve this yet, but we do have this statement in blue, which we can do exactly the same for. So this statement in blue, we can say that this is the same as x minus 100 over y minus 100 is equal to 8 over 15. 8 over 15. And now if we cross multiply, we're going to be left with 15 times x minus 100 is equal to 8 times y minus 100. So let's expand the brackets. So we've got 15x minus 1500 is equal to 8y minus 800. And then how shall we do this? Let's get all of the variables on the left and the numbers on the right. So we've got 15x, and then if we subtract 8y from both sides, and then on the right, negative 800 plus 1500 is positive 700. Okay, so we've got our two equations now. So I'm going to write them both up here. We've got 15y minus 22x, and that is equal to 280. And then over here we've got, if I switch them round, we've got, let's put the y's together. So we've got negative 8y plus 15x, and that is equal to 700. So now we've got a pair of simultaneous equations. Now we can either equate the y's or equate the x's, and I'm thinking to equate the y's just because they're smaller. So to get the numbers for the y's the same, I'm going to multiply this equation by 8, and I'm going to multiply this equation by 15. I'm obviously going to do the same to both sides. Obviously, I don't want to change the value of, or change the equations, so I need to keep them balanced. So let's first of all focus on the top equation. 15y times 8, that's going to be 120y. Negative 22x times 8 is going to be negative 100 and, oh, what's this? So 20 times 8 is 160, 2 times 8 is 16, add them together, that gives us 176. And then on the right hand side, 280 times 8, 0 times 8 is 0, 8 times 8 is 16, carry the 1, 2 times 8 is 6. Oh, sorry, no, I've done that wrong. Let me just go back. 8 times 8 is 64. So 64, and then 2 times 8 is 16, plus the 6 is 22. Okay, so this is actually quite a tricky question, especially for a non-calculator paper. But let's keep going. Let's do the second equation. So we're going to have negative, this is 120. So 120, obviously it had to be 120 because we're equating the y's. 15x times 15, that's going to be plus 225x. 700 times 15, well, 7 times 15 is 105. So it's going to be 10,500. Right, now what we're going to do with these equations, we're going to add them together, because if we add these together, that will get rid of the y's. So let's add these equations together. These will just cancel. 225x minus 176x, that's going to be 49x. And then add these together, that's going to be 12740. Okay, now we just need to divide by 49. So, right, to do this, how am I going to do this? I think I'm going to just do long division. I can't think of an easier way of doing this. Yeah, I think I'm just going to do long division. So yeah, let's do that. So 49 into 12740. 49 does not go into 1. It does not go into 12. It does go into 127, and that's going to go 2 times. So 2 times 49 is 98. Subtract. So that's going to give me 29. Is that right? 29. Yeah, I think 29. Bring down the 4. So 49 into 294. That's going to be 6, I think. Let's just double check. So 49 times 6. 9 times 6 is 54. 4 times 6 is 24, plus 5 is 29. It goes exactly. So it's exactly 6 times. 6 times 49, we just worked out, is 294. So if we subtract, we get 0, bring down the 0, 49 goes into 0 times. So we know that x is equal to 260. So we have figured out our value for x after a lot of hard work, £260. And now we need to work out what y is. So we've actually got 4 equations we can use here. So I think the one I'm going to use is, we've found our value for x. Let's use this one down here. That seems the easiest one to use. So it's going to be 15 times x, which is 260, minus 8y is equal to 700. So now what is 15 times 26? Let's just do it up here. 26 times 15. Right, lots of long multiplication and division practice going on here. 6 times 5 is 30. 2 times 5 is 10, plus 3 is 13. Put the 0. 1 times 6 is 6. 1 times 2 is 2. Add them together. 0, 9, 3. So that's 26 times 15, but we got 260. So we just need to add a 0 onto this. So it's going to be 3,900 minus 8y is equal to 700. Let's add 8y to both sides. So 3,900 is equal to 8y plus 700. Now subtract 700 from both sides. We get 3,200 is equal to 8y. And I think I'm on the right track after all of that, because this does look like it's going to divide quite nicely. So if we divide both sides by 8, we get 400 is equal to y. So this has been a lot of effort for 4 marks, but y, it looks like, is equal to £400. So I think I need a bit of a break after that question, but I can't do that. So let's go straight on to question 15. Question 15. A solid wooden sphere has a radius of 5.97 centimeters. Work out an estimate for the volume of the sphere. Give your answer in terms of pi. Now we've been given the formula, which is quite nice. So the formula for the volume of a sphere is 4/3 pi r cubed. Now the key word in this is estimate. So when we've got a value like this, 5.97, instead of 5.97, well, we can say that that is approximately 6 centimeters, and that's obviously going to make our workings out a lot easier. So that is the radius. So all I'm going to do is plug that radius into our formula. So it's going to be 4/3 times pi times our radius cubed. So it's going to be 6 cubed. Okay, so what can we do? Well, actually, I'm going to simplify this slightly. So we've got 4/3 times 6 times 6 times 6 times pi. I've just written it out like this because I can see that we can simplify this fraction. So we've got 6 divided by 3 is 2. So this, I could say 4 times 2 times 6 times 6 times pi. Okay, I've just simplified this. Instead of working out what 6 cubed is, I've just simplified this. I can see I've got 6 in the numerator and 3 in the denominator. So this here just converts to 2, really. Okay, so what can we do now? We've got, this is 36. I know that's 36. This is 8. 4 times 2 is 8, so it's going to be 8 times 36 times pi. And I'm just going to do long division now. So 36 times 8. 6 times 8 is 48. 3 times 8 is 24, plus 4 is 28. It's 288. So it's going to be 288 pi. So that is my answer. Right, now let's take a look at part B. The sphere has a mass of 1,002 grams. Richard wants to work out the density of the wood. Okay, it's a wooden sphere, so he wants to work out the density. In his calculations, he uses a radius of 6 centimeters and a mass of 1,000 grams. Is his answer an overestimate or an underestimate of the actual density? Explain why. Now, first of all, we need to know how to calculate density. So the formula for density is mass over volume. Now, we can see that in Richard's calculations, he used a radius of 6 centimeters and a mass of 1,000 grams. Now, the true mass is actually 1,002 grams. So the number that Richard's using is smaller than the true mass. So I'm just going to write in here smaller. We don't need to use any figures for this. And the volume, so, well, we're not explicitly told the volume, but we can see that action. Now for the volume, we need to think about the radius, because obviously the radius determines the volume. So in Richard's calculations, he's using 6 centimeters, whereas the true radius is 5.97. So he's using a bigger radius, which will in turn give him a bigger volume. So I'm going to write in here bigger. So his calculations are going to give him a bigger volume than the true volume. Now, if we've got something that's smaller or small divided by something that's big, we're going to get a small answer. So we're going to get a smaller answer compared to what the true value is. Our value, or Richard's value, is going to be smaller because he's dividing by the numerator is smaller and the denominator is bigger. That's going to give a smaller answer. So is he overestimating or underestimating? Well, he is definitely underestimating. So it is an underestimate. And we need to explain why. So because a smaller number divided by a bigger number gives a smaller answer. Gives a smaller answer. And that might not be the best way of saying it, but if you just put something along those lines, then you will get the full marks for that. Okay, let's move on to question 16. Question 16. Prove algebraically that 4n plus 1, all of that squared, minus 2n minus 1 is an even number for all positive integer values of n. So we've got this expression here. Now the first thing I'm going to do is just simplify this. So first of all, let's focus on this part here. So I'm just going to rewrite this as 4n plus 1 times 4n plus 1. And then we've got minus 2n minus 1. So I'm going to expand these brackets, and for this one I will use the FOIL method. So 4n times 4n, that's going to be 16n squared. 4n times 1, that is plus 4n. 1 times 4n, well, that's another 4n. And then 1 times 1 is 1. So plus 1. And then I'm going to expand this bracket. So we've got negative times 2n, that's negative 2n. And then we've got a minus negative 1, that's plus 1. So this bit here, a lot of people slip up on, is they'll just write minus 2n minus 1. But we're subtracting the 2n, and we're also subtracting the negative 1, which is where we get the positive 1. Okay, let's simplify this now. So we've got 16n squared. We've got 4n plus 4n, that's 8n. 8n minus 2n is 6n, so plus 6n. And then we've got 1 plus 1, which is plus 2. Now, we can't simplify this anymore, but we need to prove that this is an even number. So for any value of n we put in here, we will always get an even number. And the key thing to do is, if something is even, we know it's divisible by 2. So can we divide this by 2? Well, sure we can. Each of these terms is divisible by 2. So let's factor out a 2 from this expression. And then in our brackets, we're going to have 8n squared plus 3n plus 1. So basically showing this proves that it is an even number, and we can just say, if we just give an explanation, we can say that as we have factored out a 2, the expression must be divisible by 2. Divisible by 2. So as long as we've gone from this to this, it's exactly the same expression, but we've just written it in a way where we were able to factor out a 2, so therefore demonstrating that it is divisible by 2. Question 17. Samantha has 10 black socks, 8 white socks and 2 blue socks. She picks 2 socks at random without replacement. Calculate the probability she chooses 2 socks of the same colour. Okay, for this, I think I'm going to do a probability tree. So there's 3 different coloured socks. So we've got black. I'm just going to put BK for black because there's 2 B's. So we've got black, white and blue. Now, what's the probability of picking a black? Well, there's 10 black and there's 20 socks in total. So it's going to be 10 over 20. Now, I'm not going to simplify this. You could write a half, but my advice to you, whenever you're dealing with probability trees where you've got more than one strand, because we're going to have another strand because we're picking 2 socks, is that don't simplify them, and you'll see why a bit later on. So the white, what's the probability of picking a white? Well, we've got 8 out of 20, and blue, there's 2 out of 20. Okay, let's go on to the second pick. So the second pick, we can either have black, white or blue, black, white or blue, black, white or blue. So black, white, blue, black, white, blue, black, white or blue. Okay, what's the probability of picking a black sock, given that we've already picked a black sock? Well, now we only have 9. We only have 9, and there's only 19 left over. White sock, well, we've still got 8, so it's going to be 8 over 19. And blue, we've still got 2, so it's going to be 2 over 19. Now let's think about a black sock, given we've picked a white sock. Well, we've still got 10 black socks left, so it's going to be 10 out of 19. We've already picked a white, so instead of 8, now it's going to be 7, so 7 over 19. And blue, we've still got 2, so 2 over 19. And now a black sock, given we've picked a blue sock, well, there's still 10, so 10 over 19. There's still 8 white socks, so 8 over 19. And blue, we've only got 1 blue left now, so it's going to be 1 over 19. Now, we need to calculate the probability she chooses 2 socks of the same colour. So we're going to go black, black. We're going to calculate this probability. We're going to go white, white. And we're going to go blue, blue. So when we're calculating probabilities of multiple events, we need to multiply the probabilities. So it's going to be 10 over 20 times 9 over 19. This one is going to be 8 over 20 times 7 over 19. And this one down here is going to be 2 over 20 times 1 over 19. So all I'm going to do is multiply the numerators and multiply the denominators. 10 times 9 is 90. 20 times 19 is 380. 8 times 7 is 56. So this is still 380. 2 times 1 is 2. This is still 380. Now, hopefully you can see why I haven't simplified. And that's because all my denominators are 380. So I just need to add all of these together. So all I need to do is add the numerators. So 90 plus 56 plus 2. Okay, 6 plus 2 is 8. 9 plus 5 is 14. So we get 148. So my answer is 148 over 380. You do not need to simplify your answer unless it tells you to in the question. So leaving it like this will give me 4 marks. If you have simplified it, let's see what the answer would have been. So let's divide both numbers by 2. We would get 74 over 190. And we can divide both numbers by 2 again. That's 37 over 95. And we can't simplify that anymore. So either one of these would be correct. Question 18. A straight line passes through the points A, which is 1, 4, and B, 5, 16, which we can see on the graph here. We need to find the equation of the line perpendicular to AB that passes through the midpoint of AB. So we've been given the line, this line here, which has AB on. We need to find the equation of the line perpendicular to this line that passes through the midpoint. Now, because we're looking for the line that's perpendicular to this one, we know that the gradient of this of the line we're trying to find is going to be the negative reciprocal of this line. So first of all, let's work out the gradient of AB. So gradient of AB. Well, we've got 2 points on the line, so we can work out the gradient. The gradient is the change in y over the change in x. So it's the change in y over the change in x. So the change in y is going to be 16 minus 4. 16 minus 4. And the change in x is 5 minus 1. So 16 minus 4 is 12. And 5 minus 1 is 4. 12 divided by 4 is 3. So the gradient of AB is 3. Therefore, the gradient of the line we're looking for, so the one that's perpendicular to this, is the negative reciprocal of 3. So it's going to be negative 1/3. So that is the gradient of our line. And now we need to know what the y-intercept is. Well, we know one of the points on the line is the midpoint. So let's calculate what that point is. So what are the coordinates of this point? Well, it's going to be the midpoint. The x-coordinate is going to be the midpoint of these two, which is 3. So we've got 1 and 5, so the midpoint is 3. And then the midpoint of 4 and 16 is going to be 10, I believe. Is that right? 10. 16 plus 4 is 20. Divided by 2 is 10. Yeah. So we're just finding the mean of these two, which is 10. So now we have got the gradient and we've got one of the points on the line. We can use that to work out the equation of the line. So the equation of any line we can write in the form of y equals mx plus c. Now we can use these points and the gradient. So our y value is 10. So it's 10 is equal to the gradient, which is negative 1/3, times x, which is 3, plus c. Now I'm just going to come up here to give myself a bit more room. So we've got 10 is equal to negative 1/3 times 3. That's just negative 1. So negative 1 plus c. And then if we get c on its own, if we add 1 to both sides, we have 11 is equal to c. So now we've got our y-intercept. So we've got our gradient, we've got our y-intercept. So the equation of the line will be y is equal to negative 1/3 x plus 11. So that will be my answer. Y is equal to negative 1/3 x plus 11. Question 19. BCEF is a parallelogram. The point C is a point on the line BCD. such that the ratio of BC to CD is 4:7. So the ratio of this line to this line is 4:7. FD, which is this long line here, and CE, which is this line, meet at the point G, and we're told the vector BC is equal to A, and the vector BF is equal to B, which is already given to us on the grid, on the graph. So we need to work out GD, work out the vector GD in terms of A and B, and give your answer in its simplest form. So the vector that we need to calculate is GD. So we're starting here. So G, we're going to go to C, and then we're going to go along to D. That's the vector we're trying to work out. Now we can work out the vector CD using the fact that we've got this bit of information up here. So we know that the ratio BC to CD is 4:7. So how many times bigger is CD compared to BC? Well, it's 7/4 times bigger. So to work out how many times bigger, we just do 7 divided by 4, which gives us 7/4. So this is 7/4A. So we've worked out the vector CD. Now we just need to work out the vector GC. So I can see that GC is going to be some multiple of B, because these two lines are parallel. So if we've got lines that are parallel, they're going in exactly the same direction. They're both going to be B, but we can see that this is just a smaller version of this one. So this is going to be some multiple of B. So how can we work out how many times smaller it is? Well, we can use similar triangles or similar side lengths because of the fact that we've got parallel lines. So what I can say is the ratio of this length to this length is going to be exactly the same as the ratio of this green line to the red line that I've just drawn over, because all of these side lengths are in proportion because they're similar triangles. So let's work out how many times bigger the green side lengths are compared to the red side lengths. So this one at the bottom here, BD, we know that BD, oh, that's right, not BC, BD, oh, I forgot to put arrows on my vectors, apologies. So the vector BD, what is that going to be? Well, that's A plus 7/4 A. So we could say 4/4 A plus 7/4 A, that is going to be 11/4 A. And we know what CD is. CD is 7/4 A. 7/4 A. So how many times bigger is the green side length on the base compared to the red base? Well, we're just going to do 11/4 divided by 7/4. So another way we could do this is we can just do the, instead of multiplying by this, we can just, instead of dividing by this fraction, we can multiply by the reciprocal. So multiply by 4/7, and that will give us, with the 4's cancel, so that's going to be 11/7. So we know that the green side lengths are 11/7 times bigger than the red side lengths. So, or another way we could say it is we could say that the red side lengths are 7/11 times bigger, or how am I trying to say this? Basically, this side length here, this red side length is 7/11 of the green one. So this is going to be 7/11B. Hopefully you can see that if this is a 7/11 B, if we multiply that by 11/7, we're just going to get back to B. So because this is smaller, I've just done the reciprocal of this. So now we have both our side lengths in terms of A and B, we can give our answer. So GD is going to be equal to, where have we got? We've got negative 7/11 B, because remember, be really careful, we're going in this direction. So the original vector was going this way, we're going the opposite, so it's going to be negative 7/11 B plus 7/4 A, plus 7/4 A. And you can obviously switch these round, so you could say 7/4 A minus 7/11. B, either one of these would be correct. So the key with this question, these are quite tricky. A lot of people find these vector questions tricky, is to recognize that we've got similar shapes or similar triangles, similar lengths, however you want to say it, and that one of them is just going to be a scalar multiple of the other. So as long as we've got parallel lines, that's the key thing in here. We've been told that they're parallel lines. Well, we know that one of them is just a scalar multiple of the other, and to work out what the actual value is, we can use the similar side lengths for the other side lengths, because we were given both of them. We knew that the long one was 11/4 A. We knew the small one was 7/4 A. So we could then work out how many times bigger and use that on these side lengths over here. Question 20. Solve the simultaneous equations. So looking at our equations, we've got one with quadratics in, and we've got one linear equation. So whenever you have this setup where you've got one quadratic and one linear, the best way to solve this is to substitute the linear equation into the quadratic equation. So if we start with the linear equation, we've got x plus 2y is equal to 1. Now I'm going to have to make one of these the subject. I'm either going to make x the subject or y the subject. So I'm going to make x a subject just because we've got x on its own at the moment and we've got 2y. So to get x on its own, I'm just going to subtract 2y from both sides. So I'm going to have x is equal to 1 minus 2y. And now I've got x a subject. So what I've got for x is 1 minus 2y. So if I now substitute that expression for x into my quadratic equation, I can then solve for I can solve for y. So wherever I see an x, I'm going to replace that with 1 minus 2y. So we've got x squared. So that's going to be 1 minus 2y, all of that squared, plus y squared. And that is going to equal 1. So now I'm going to expand these brackets. So I'm just going to do this in full. 1 minus 2y times 1 minus 2y. I just want to make sure I show every step that I'm doing. Plus y squared is equal to 1. So I'm going to FOIL this out. So 1 times 1 is 1. 1 times negative 2y is negative 2y. And then we've got another negative 2y. And then we're going to have positive, because it's negative times a negative. So positive 4y squared. And then we've got plus y squared. And that is equal to 1. So we've got a quadratic equation here to solve. So whenever we've got a quadratic equation, we always want it in the form of ax squared, or actually I'm going to use y's just because I've got y's. So ay squared plus y plus c is equal to 0, where c is just a constant term. So we always want 0 on one side of our equation. So, went too far. So I'm going to first of all simplify all of the y squared terms. So we've got 4y squared plus y squared. That's going to give me 5y squared. Now let's simplify the y terms. We've got negative 2y minus 2y. That's negative 4y. And then I want to put put 0 on the other side. So to do that, I need to get rid of this 1. So if I subtract 1 from both sides, I've got 1 here. I'm going to have 1 minus 1. So that's going to be 0. So if we think about our constant terms, we've just got 1 over here and 1 over there. Or another way you can think about it is those two just cancel. So those two just cancel. So all we're going to be left with on the left-hand side is 0. So now we can, because we don't have any constant terms, this is much nicer, much easier to solve. So we don't need to use the quadratic formula. What we can do is we can factor out a y. So we can factor out a y from these two terms. So we're going to have y, and then in brackets we're going to have 5y minus 4. And that is going to equal 0. And notice there's going to be two solutions to this. So either y equals 0, so y equals 0, or 5y minus 4 is equal to 0. Notice how if any of these terms are 0, our answer is going to be 0. So if y is 0, 0 times anything is going to be 0. And if 5y minus 4 is 0, well then 0 times whatever we've got here is also going to be 0. So let's just solve this second equation. We're going to have 5y is equal to 4, and then y is equal to 4 over 5. So we've got our two solutions for y, but this isn't our final answer because we haven't worked out what x is now. So we're going to have to substitute these values for y back into our original equations. It doesn't matter which one we use, but I'm going to use the linear. I would recommend always using the linear one just because it will be easier. So let's first of all start off with when y equals 0. So when y equals 0, we're going to have x plus 2y plus 2 times 0 is equal to 1. So obviously 2 times 0 is just 0. So we're going to have x is, so it'd be x plus 0 equals 1, or just x is equal to 1. Okay, now let's work out when y is equal to 4/5. So when y is equal to 4/5, we're going to have x plus 2 times 4/5 is equal to 1. So if we just multiply this out, x plus 2 times 4 is 8, so it's going to be 8/5 is equal to, I'm just going to write, instead of writing 1, I'm going to write 5/5, just so we've got fifths, like we've got even number of fifths. So then if we subtract 8/5 from both sides, we're going to have x is equal to -3/5. So now we've got our solutions for x. So we just need to put these in the answer line, but make sure you line them up. So which ones go with which? So we can say that x is equal to 1 and y is equal to 0. Or x is equal to -3/5 and y is equal to 4/5. So we're always, not always, but most of the time you're going to have two solutions to anything involving quadratics. Question 21. ABCD and LMNO are squares. An angle CBL is equal to x. We need to prove that triangles ABO and CBL are congruent. So the word congruent just means that all side lengths and all angles are exactly the same. So if we put one triangle on top of the other, they would be identical. So obviously the orientation doesn't matter. We could turn it around, but they have to sit, once we've got them in the right orientation, they would sit directly on top of each other. So ABO, what's that? Let's highlight that. So ABO is this triangle here. And CBL, so that is this one on the right hand side. I'm just doing these in different colours. Hopefully it pops out. Oh, let me do that again. This is CBL. So they obviously look congruent, but we need to prove that. And we're told that this angle is x. So straight away, I could see that this side length is equal to this side length because they are squares. We're told that ABCD is a square. So we can say that AB is equal to BC. And the reason for that is that they are both sides of a square. Okay, so I've just given my reason for stating why AB is the same as CD. Now, what I'm going to do now is we need to use this square in the middle as well. So, because this is a square, we obviously know that these are right angles. We know that there's a right angles in a square. So, if they're right angles, this angle over here is going to be 90 degrees. And this angle is also going to be 90 degrees. So that's another thing we can say. We can say that BLC, so angle BLC, is equal to angle BOA, angle BOA. And we don't need to give a reason for that now, because you can use what you've done on the diagram. I've sort of shown that these are squares, these are right angles. So that's absolutely fine just to leave it like that. Now, what else can we see? Now, we've got, what I'm thinking is that we've got two angles in our triangles. Or if we focus on the red triangle, we can see we've got two angles. So this angle, so angle BCL, angle BCL, well, that's going to be whatever's left over from 180 degrees, because we know angles in a triangle sum to 180. So it's going to be 180 minus 90 minus x. And let's just simplify that. So 180 minus 90 is 90. So it's going to be 90 minus x. So this is 90 minus x. We need to prove, or we need to find out why this would be 90 minus x. And now, hopefully you spotted this. It took me a while to spot it. I have paused the video because I didn't do this straight away. But this is obviously a right angle because of the square, this larger square. I was obviously focusing on the smaller square before, but if we focus on the larger square, angle ABC, well, that's 90 degrees. So this small angle is going to be 90 minus this angle. So this angle is ABO. So angle ABO is going to be 90 degrees minus angle, I could just write X, but I want to show what I'm looking at. So angle CBL or BCL, whichever way. Sorry, no, it is going to be CBL. Angle CBL, which is the same as 90 minus X. So now we've proved that these two these two angles are the same. These two side lengths are the same. And now the last thing to do is to prove that this angle here, this angle here is x. We need to prove that this angle is x. Because we've got an angle, a side length, we need another angle. So how can we prove that this is x? Well, we've got two of the angles. Now we've got two of the angles in our blue triangle. We can just calculate this last angle. So the last angle, angle BAO, angle BAO is going to be 180 degrees minus 90 minus this angle, which we've just calculated. So that ABO, that was 90 minus x. So I'm just going to put it in brackets, 90 minus x. So we've got 180. Oh, well, 180 minus 90 is just 90. And then we've got minus 90. And then if we're subtracting negative x, that's just going to be plus x. So 90 minus 90 is 0. So we're just left with x. So that is, we have just proven that is exactly the same. So we can now say that triangle ABO is congruent. So that is the symbol for congruent, or you could just say is congruent. If you don't know that symbol, is congruent to triangle CBL. And that is through, we've got angle, side, angle. Angle, side, angle. So if we just go through this, so let's just color match these. So this angle corresponds to this angle. Those are the same. They are both 90 minus x. And then we've got the side lengths. So this side length and this side length are equal because they're a square. And finally, this angle is equal to this angle. They are both x. So we've given our workings out, and we've given a final concluding statement to say that they are congruent through angle, side, angle. You could have possibly used a different congruency axiom. So there may be more than one answer for this. And if I just check the answer sheet, there isn't a mark scheme for this, but There is an answer sheet. They've also used ASA, but there may be a different one you could use. Okay, let's move on to question 22. Question 22. The diagram shows a kite ABCD. Given that BC is equal to CD, which is X, and AB is equal to AD, which is 5, and angle BCD is 60 degrees, we need to prove this statement here. So the cos of BAD is equal to 1 minus x squared over 50. Okay, right. Now we've got a kite, but I'm just going to separate this into two triangles. So I'm going to draw a line from B to D. That's given me two triangles. Now this triangle is an equilateral triangle because this side length is the same. So this side length and this side length are equal, and this is 60 degrees. So this also will be the same length here. And just to show you kind of why that would be the case is that these two angles are the same. So this angle and this angle are the same because this is a horizontal line and these two side lengths are the same. So now we've got a 60, 60, 60 triangle. This is an equilateral triangle, so we know that all side lengths and all angles are equal. So on my diagram, I could just label this as X. Now, my statement involves cos, and so I'm going to use the cosine rule. Now, can't quite remember what the cosine rule is for angles, but I do know what it is for side lengths, so I can just use that and then rearrange the formula. So I know that a squared is equal to b squared plus c squared minus 2bc cos a. That is the cosine rule. And if we think about our diagram, what's a, b, and c? So let me just use red for this. So if this is our angle A, this is our side length A, and then B and C, it doesn't matter which way around we put those. So I need to obviously work out what the cosine of this angle is. So I need to rearrange this formula to make the cosine of A the subject. So the first thing I'm going to do is I'm just going to add all of this minus 2bc cos A to the other side, just so we're dealing with positives. So we've got a squared plus 2bc cos A, and then that equals b squared plus c squared. And now I'm going to subtract a squared from both sides, so I'm going to be left with 2bc cos A is equal to b squared plus c squared minus a squared. And now I want cos of A on its own, so I'm going to divide both sides by 2bc. So we're going to be left with the cos of A is equal to b squared plus c squared minus a squared, all of that over 2bc. Now you may have already known this formula. So this formula, it is given to you in textbooks and teachers do teach it to you. But if you didn't know it, hopefully you know what the basic cosine rule is for side lengths. You can just rearrange this formula to get this formula here. So, excuse me. Now we've got our formula, let's plug in our numbers. So we've got the cosine of A, which is actually, instead of writing cosine of A, we can write cosine of BAD. BAD, cosine of bad. And this is a bad question. It is the last question, so it's a good question. So cos of bad is equal to b squared, so that's going to be 5 squared plus another 5 squared minus a squared. Well, a in this case is x, so it's just x squared. And then all of that divided by 2 times 5 times 5. So now we just need to simplify. So 5 squared is 25. 25 plus 25 is 50. So we're going to be left with 50. And I can see there's a 50 here, so that's promising. Minus x squared. And then all of that is divided by 2 times 5 is 10. 10 times 5 is 50. So we're left with this. Now, hopefully that is the same as this. So we can just rewrite this as this is equal to, we're dividing this whole expression by 50. So this is the same as 50 over 50 minus x squared over 50. I've actually gone to kind of doing this, I've gone a step backwards. So if we had this, we can see that we've got a common denominator of 50. So this is the same as 50 minus x squared, all of that over 50. And obviously 50 over 50 is just 1. So it's going to be 1 minus x squared over 50. And lo and behold, that is exactly what they've got in the, we have to prove. So we have proven that cos of BAD is equal to this expression over here. So that was the last question in this paper. So hopefully any of you sitting your GCSEs in the next couple of weeks, you found that useful. And obviously this was for paper 1, but I will be doing paper 2 and paper 3. And I'm probably going to do a couple of those. So make sure you check those out on my channel. I have already got loads of other walkthroughs that I've gone through in previous years, and they're all posted on my GCSE walkthrough playlist. So please have a look at those walkthroughs and try and get as much practice as you can with answering these types of GCSE style questions. So thanks again for watching. Good luck in your exams, and hopefully I'll see you in the next video. Take care.